Today we're going to look at lesson 7.1, which is about zero and negative properties of exponents. So our objective today is you're going to simplify expressions involving zero and negative exponents. So we are going to start with the zero power property. Here is our definition. It says, let x be a non-zero number. So if something is non-zero, it means that it can be any number except for zero. So if that is the case, this is what we know. We know that x raised to the power of 0 is going to equal 1. And once again, x, which is representing our base, will never be 0 because it is a non-zero number. Okay, so essentially what this is telling us that whatever our base is, if it's raised to an exponent of 0, our answer will always turn into the number 1. So let's take a look at a couple of practice problems. We have 4 raised to the power of 0. So notice that my base is 4. That's kind of representing the x in that definition that I just showed you. So because my base is raised to a power of 0, automatically my answer is just 1. If I look at the second example, we've got negative 1 to the power of 0. Notice that there are no parentheses around that negative and the number. So if we think back to the lesson from yesterday, that means that our base is really a positive 1, because what I want to think about is I want to think of this as negative 1 times 1 to the power of 0. Okay, if there are no parentheses, then the negative is not a part of that. And so now that I know that it's really just 1 to the power of 0, we know that we are going to turn that into a 1 because that's our definition. So this problem tells us that we want negative 1 times 1. Well, negative 1 times 1 is going to give us an answer of negative 1. In the next example, in parentheses, we have negative 3x to the third, or xy to the third, and that whole thing's raised to the power of 0, and that's being multiplied by xy. So notice that everything that I have here in parentheses is being raised to the power of 0. So that means that that whole entire parenthesis, because it's raised to the power of 0, will just turn into the number 1 because of our definition. But now the x and the y that are outside of the parentheses, those are not being raised to the power of 0. So I'm still multiplying then 1 times xy. So if I was to multiply, well, anything times 1 is just that term. So it just then turns into xy. If you keep the 1 out in front, that's not a big deal. That is the same answer. Okay, so you just want to make sure anything to the power of 0 is 1, but make sure you know what the base is. If there are no parentheses, you can't include negative signs. Sometimes you'll have terms outside of the parentheses and you don't have those raised to the power of 0. So it really just depends on the problem. The second thing that we're going to talk about is this negative exponent property. So here's our definition. We're going to let x be a non-zero number. So once again, that means that it can be any number except for 0. And we're going to let n be an integer. An integer is just a number on the number line. So like negative 1 and 0 and 1 and all that kind of stuff. So n can be 0, but x is non-zero. With this, here is my definition. I know that x to the negative nth power is really going to equal 1 over x to the positive nth power. Okay? Or I can say that 1 over x to the negative nth power is going to equal x to the power of n. All right? So notice that in this case, essentially what this definition is telling us is that we never want to have negative exponents. So we technically are always going to change negative exponents into positive exponents. See how technically, I'm going to do it in a different color. Technically, that x to the negative nth power is really a fraction if we put it over 1. So it starts in the numerator. To turn that exponent positive, notice that we had to move it down to the denominator. If I start with that exponent negative in the denominator, technically, then it gets moved up to the numerator, which then changes its exponent positive. Okay, let's take a look at some practice problems here. So we're looking at 4 to the negative second power. So we never want to have negative exponents. If I don't see a fraction, but I see a negative exponent, the very first thing I'm going to do is I'm going to make it a fraction. So I'm going to put it over 1. So right now, my negative exponent is located in the numerator of the fraction. So to change that exponent to positive, I actually then want to move it down to the denominator. I keep the base exactly how it is. So since 4 was in parentheses and that's the base, when I move it down to the bottom, it's still 4 in parentheses. So the base does not change. But that 2 is now going to turn positive because I moved it down to the denominator. Since there was nothing else located in the numerator, I'm going to put a 1 on the top. And so this would be my new answer. Technically, because my denominator is 4 squared, that is something that we can easily multiply out. Remember, the exponent tells us how many times we should see that base. So I should see it 2 times. So technically it's 4 times 4 in the denominator. And we can multiply that out. 4 times 4 is 16. So I really have then 1 over 16. So those two things that I have circled are the answers. Anytime I have an exponent that is a 2, you can go ahead and actually multiply it out. So 4 squared is why now I have 16 in the denominator. If I look at the second example, I've got 1 over 8 to the negative third power. So notice that I see a negative exponent, but it's in the denominator of a fraction. So that means that I already have a fraction. I don't have to worry about putting anything over 1. If I start with that in the denominator, I actually then need to move it up to the numerator. So remember, 8 is the base. I keep the base exactly how it is. But I'm going to then have a positive 3 because then in my denominator, it's technically a 1 once I moved that term up. Okay, so then if it's over 1, you don't really have to write it then. You can just write that this is 8 to the third power. If you want, we can multiply that out. It's not too hard to see that 8 to the third power is 8 times 8 times 8. And we do have a calculator, so 512 would be my answer. So I technically have 2 answers. It's 8 to the third power, but that's really 512. Okay, I've got one more example to look at. We've got 4 to the negative third power times x to the third power. Notice that in this example, I see that one of my bases has a negative exponent. The whole point is that I never want negative exponents. Because I don't see any fractions, I'm going to make it a fraction by putting that whole thing over 1. I only need to move terms that have negative exponents. So only this 4 has a negative exponent. The x has a positive exponent. Since x to the third power is on the top and its exponent is positive, I get to leave that there. But the base of 4, I want to move that down to the bottom because then the exponent of 3 is now positive. So sometimes you will move terms, but other times you may not. So you do have to be careful. You only move things when you have negative exponents. Okay, once again, because we have something raised to the third power, when I have a base that is a number, I can very easily, as long as my exponents are 2 or 3, it is pretty easy for us to multiply that out. So I'm going to do that. So remember, 4 to the third power, if I think of it in terms of repeated multiplication, would be 4 times 4 times 4. So I keep the x to the third power on the top, but 4 times 4 times 4 is going to give us 64. So x to the third power all over 64 is the other way that we can represent this answer.